Hi, we're Wiser Systems. I'm Seth Holler, CEO, and here we have
Logan Maxwell, wearer of many hats.
again, just the two of us. And today we're talking about indoor positioning systems in manufacturing and how you choose it. And to start off, maybe people have heard IPS. They're more likely to have heard what RTLS is. And I think you have a comment here, Logan.
Right, and I think there's probably a large amount of overlap between these two terms. And I think where IPS as a term, an indoor positioning system, is trying to differentiate itself from a real-time location system is, number one, the indoor portion of that, right? A real-time location system could utilize long-range cellular or GPS satellites to find the position of something outdoors around the globe to a pretty fine degree of accuracy. What an indoor positioning system is going to do is try to replicate that inside a campus, inside a facility, inside these sorts of things.
Areas where GPS doesn't work, cellular doesn't work, so you have to move more to other technologies to get accurate positioning.
Right, exactly. So wherein the others are satellite-based outdoors, this is going to be trying to replicate that indoors. Now the other thing that it is trying to differentiate is the positioning part of this, where a real-time location system, although I will say it's a little bit of a misnomer and a little bit of a marketing faux pas in my opinion, some systems will market as a real-time location system because as you barcode scan or you RFID scan that item at the gate or station, you would have had the real-time location.
You know it's at that station or location, but you don't get those updates all the time, right?
Right, and so the real-time, I think it's a little bit of a fudge, but you could say the real-time location system is we have a list in real time of the locations things were scanned
Basically timestamps of where what areas they were at,
and
if you have that
and
reader.
I'm viewing that currently real time, right? So it's a little bit of a misnomer, but an indoor positioning system in terms of the term is trying to kind of separate itself from that. These are systems that work indoors where you have an actual updated to the second or multi-second location. That would be a coordinate value set, whether it's a GPS grid or its own referential grid. You would have a coordinate updated position of the way things are moving internal to your plant or facility.
Right. So in talking about IPS, or indoor positioning systems, there are certain applications. And what applications might those be? I'm sure there's varied applications, and what comes to my mind is asset location, finding assets, but must be some other ones available as well.
Yeah, and those classes of assets can really vary as well, right? So we're finding our gauges and our test equipment and our fixtures. We're also finding the whip itself, or the carts or the bins or the reels that are carrying that whip, right? And in finding those assets real time, you're also generating historical coordinate points of where those assets were. And so that is the kind of a large part of the same use case can kind of be bifurcated into two. Right. So finding our assets, we also know where they were, and that can be your bottlenecks in your production flow. Right. So the historical data, the integral, so to speak, of how things have moved across your facility is its own use case in that way. Right. So
and that's where they talk about Industry 4.0, where they're effectively getting insight into where things are located, not just visibly, but on the digital side. Like on your server when things moved around and have a permanent record of that.
Yes. A third and potentially controversial use case can be the tracking of people. So a lot of times if that's done for lone workers, safety situations, it's totally fine. There can also be production tracking in terms of people. So proximity to machine, how often are they near the thing that they need to be doing, and used as a more of a managerial thing, which can have some complexities in terms of HR and labor laws as well.
And on the safety side, we've heard many cases of where people wanted to detect people in the presence of forklifts to prevent injury or some sort of collision.
Right, because there are other things moving in your facility, right? And so you can track the people side of that, but then if you split that use case even further, there is also automating and understanding in your facility how these other items are moving. So that'd be forklifts, AGVs,
right.
Any sort of machinery, And you can theoretically, if you have the location of the people or objects or whip or carts or bins,
you can start automating certain elements on the physical level.
Exactly, right? Open up a gate when you need to, close it when you need to, turn on or off a machine or on and off a light or a buzzer. All of that is possible when you have indoor positioning systems. You're right, separating itself from RTLS, so to speak, real-time location. You have to have indoor position in order to do those things.
Well, let's jump into some of the technologies that people associate with the IPS technology.
Sure.
Wiser, for example, uses UWB, but go ahead, talk a little bit about that.
There's a lot more kind of the conventional ones that you would probably know as a consumer. So people are using Wi-Fi and Bluetooth to do similar things, where using the same technology you would use to pair your headphones to your phone, and using angles and signal strength in order to find location indoors. Wi-Fi will do the same thing. The really convenient thing about Wi-Fi is a lot of facilities already have it, right? And so if we can utilize that same infrastructure that already exists to try to get location positioning, great. Where both of those fall short, slightly different categories. Wi-Fi tends to be difficult in cluttered environments. Also, the accuracy can be a little tough. And a lot of times the density of your Wi-Fi routers isn't enough to get the location side out of it squeezed out.
And the Wi-Fi tags themselves, it's a fairly process-heavy algorithm or protocol, so you don't get a whole lot of life out of Wi-Fi tags.
Yeah, and Bluetooth, well, it does have longer battery life,
right,
will often suffer from what we call multipath, and we actually have a video on the physics between ultra-wideband and Bluetooth, but Bluetooth, by and large, if you're in an open area with not a lot of metal and not a lot of devices, is actually really quite good at just giving kind of consumer-grade location. And that's where a lot of these systems, the original tiles, original AirTags, we're going to utilize that protocol. They've now switched to ultra-wideband because obviously it's a little better at doing the location part of it, but that isn't to say that you can't get a decent Bluetooth system if you have some of those, you don't have some of those restraints.
And ultra wideband, it's specifically designed for accurate indoor positioning. It has a wider band in the frequency domain that gives you more granular time stamping and better information in terms of where things are positioned from a technical level.
Yeah.
But in terms of the practical level, you get very long battery life, typically 3 to 5 years, depending on the size of the battery, even longer. And facility-wide, you can get real-time information in seconds. And what other advantages are there on UWB as well?
We can have a lot of overlapping tags. So if you're a pretty scaled out facility,
volume, scaling up.
If you have a large, million square feet, tens of thousands of assets, it'll still cost. Of course, there's infrastructure involved, as you can see, to put this up. But the system at a technical level is scaled to be able to manage that. So there is no technical hurdles that you have to overcome, just cost hurdles in that case.
Right, and to be clear, compared to Wi-Fi, where you already have the infrastructure, UWB and Bluetooth are a little bit different, where they require an additional infrastructure.
We've done our best to limit, of course, all the costs of all that involved, and if you are interested in some comparisons, please reach out or send in a form or contact us, as we can kind of provide that. And honestly, for us, it's pretty easy, pretty quick to get you a cost estimate of what it would take at your facility. We've intentionally made the system to be useful for small, medium, and large-sized manufacturers of all sizes. So if you're large, don't think you're counted out just because you're going to have to pay a lot. And if you're small, don't think you're going to be counted out because you're going to have to pay similar to some other large aerospace facility. It's all been scaled out to be appropriate for what you're attempting to do. So we have taken pains to try to make sure that it is affordable.
Well, great. This is our overview of indoor positioning systems. If you have any questions or you want to reach out to us, go online, hit contact us, email, call, submit a form. Any last comments, Logan?
No, it's a wide world out there. It can be confusing, especially if you're doing some web deep dives, which I'm sure you guys are if you're looking at all these different solutions. Feel free to use us as references a lot of times. Like, we're happy to talk to you, even if it doesn't seem like we're a perfect fit for your use case. We're happy to suggest other technologies. We've had to deal with and without a lot of additional technologies and partners and groups. So we may be able to provide some feedback that's useful to you, even if you don't see ultra wideband being the correct solution for you in this case. So never feel like you shouldn't reach out and let us know.
Thank you so much, and we'll talk to you later. Take care. Bye-bye.